and So my goal is to take each of these and fold it up. And then I could tape off the sides, and then I have a nice little box. Well, we started off with an 8 by 10. So we started off with this distance being 8. Let's put that on top. And then we said that this would be 10. But when I fold up these sides, I will no longer have an 8 by 10 size. Instead, I will have an 8 centimeters or 8 inches, cut out 3, cut out 3. This flap is actually going to be 2 inches. Just like this 10 minus that 6 will become, 10 minus that 6, this will be a 4-inch flap. So if I kind of draw the diagram of this, let's see how this works. We folded it up into a box. That would look something like that. Well, that box has a 4-inch by 2-inch by, how high is this box? What's the height of the box? I have a base of a 4 by 2. What is the height of the box? Yeah, 3 inches. Because each of these are 3 inches. So when I fold it up, the height will be 3 inches. So the height of this would be 3 inches. So we have a box that is 4 by 2 by 3. So the volume equals 4 times 2 times 3, which does equal 24 inches cubed. The correct answer is 24 inches cubed. Know how to do a problem like this. This is big in math. There's a lot of, and when you get to different math levels, you have to know what's happening when you cut things out and you fold it up. It's not just this class, it's going to be other classes. All right.
Could you have done area times height?
Yep. I mean, in effect, that's what I did. So 4 times 2 is our base area, right? Because it was a 4 by 2 and then it's times height. So I really did base area times height. It's just, we kind of mask it when it's a box because it's just all 3 of them multiplied together. Yes. Sure. Other questions? All right, then questions on the homework. Hamza.
So for number 19,
Okay.
we also solve it by finding the difference in volume,
Mm-hmm.
something like that.
Mm-hmm.
Do base area times the height.
I guess that's kind of what I did. I mean, we did find the pan volume and the volume, and I was just comparing the two volumes would be 810 over 960. So I did really just compare the volumes. But there are different ways to solve this problem.
Okay. I tried it doing volume is 150 equals base area, which is 120 times height. And then I got height is 1.25 centimeters. But that isn't the right answer.
Say that again.
So I did 150 equals 120 times height. So 150 is the volume, and then 120 is the base area.
Well, you can't do volume times base area, I guess. It always has to be base area times height to get a volume.
Yeah, that's what I did. I did 150 equals 120 times height.
Where'd you get the 150 from?
That's the difference between the two volumes, so 810 and then
Oh, okay.
960.
So that'd be the difference between the two volumes. Why are we multiplying it by the height, though?
No, I was doing the base area times height, so I multiplied 120 times the height.
No, that doesn't. No. Because you're taking volume and you're turning it. If you multiply volume by height, you're actually trying to add another dimension to it. We can't multiply it by another dimension because the only dimension we could get it to is fourth dimension. So you do have to get the ratios of the two things, which would be 810 over 960, which does equal 27 over 32. And then we just multiply that ratio by the pan height, and that's how high up it is. Other questions? Okay, today is me just basically giving you two formulas. Actually, just one formula. And then we're going to try a slightly harder problem, and then the rest of the time is going to be yours. All right, we did volume of cylinders and we did volumes of rectangular prisms before. We did that yesterday. So let's do the volume of the cylinder and let's do the volume of the rectangular prism. Well, the volume of a cylinder is going to equal our base area times our height. Well, our base area for this one would be pi r squared. So we'd have pi times r squared, which would be pi times 5 squared. And we multiply that by the height. Well, the height of this is 12. Once again, this is my base area times height equals volume. So our volume is going to end up equaling 300 pi centimeters cubed. All right, let's do the same thing for the rectangular prism. Rectangular prism is solved the exact same way. It's base area times height. So the volume of that rectangular prism is going to be volume equals our base area is 9 times 8 times our height, which is 12. So our volume is going to be equal. What does this one equal? Someone do that. It's like 300 something. It's something, 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 something. Yeah, 864. We don't know what it is, so let's go units cubed. Cool. All right, and the reason why we're going to do these side by side is because the volume of the cone is the exact same principle as the volume of a rectangular pyramid. In fact, let's start off with the rectangular pyramid. So we're going to start down here. In 2 dimensions, when I drew a rectangle, we said it was base times height. When I cut it in half along a slant, we created a triangle. That's how we came up with the formula for the area of a triangle being 1/2 base times height. Well, this is not 1/2 the size of this. Who wants to take a guess at how much of the volume is actually comprised here of our entire prism? So it's not 1/2. I'm telling you right now it's not 1/2. That is in 2 dimensions. 2 dimensions, a triangle is half that of a rectangle. Yeah. 3/4. It's not 3/4. We're just guessing, right? You else want to guess? We have one brave person that wants to give me a number. I'll wait. Let's wait until we get some guesses. Aryan.
2.
It's twice the size?
Yeah.
Well, this is definitely going to be smaller because I'm cutting stuff away.
Oh.
So it's going to be smaller. Kazi? It is actually 1/3. It is 1/3 the actual size. So the volume of a rectangular base pyramid is 1/3 the measure of the rectangular prism. So this one is going to be the volume. Did you already know that, Kazi? Oh. Our volume is going to be 1/3 the volume of your prism. So it's 1/3 the volume of the prism. That means that volume is 1/3 the base area times the height. Well, in this case, it's 1/3. We said our base area is going to be 9 times 8 times our height, which is 12. Realistically, we already calculated, so it's 1/3 of that 864. What does that come out to? Yeah.
288.
288?
Cubed.
288, yep, units cubed. All right, using that same idea, we're going to look at that cone. So we started with volume of a cylinder. That's going to relate to a cone. Well, the same thing is down here. This is going to be half the volume of the cylinder. So this is 1/3 the volume of the cylinder. So once again, it's just 1/3 the volume that we can calculate by base area times height. So it's 1/3 the volume of the cylinder. Once again, this is the exact same formula as down below, that it is your base area times your height. Is the height of this one 13? Yeah.
No.
No, it's not. It would not be 13. What would the height be?
12.
12. We knew that from two different places. We knew it from over here, we said it was 12. But we could have did a squared plus b squared equals c squared to come up with the 12. Or we could just notice it was a Pythagorean triple. I do want to quickly, this 13, you'd have to use that to find the surface area. This came from that pi RL. This is actually the length of your cone. This is your height of your cone is 12. Your length of your cone is 13. So we're going to have volume equals 1/3. Our base area is pi r squared. So it's pi times 5 squared times our height, which is 13. And this is going to come out to being 100 pi centimeters cubed. So all those shapes that come to the points, the pyramids and the cones, are all going to be 1/3 your base times your height. Yeah?
I thought the height was 12.
Oh, I said it. I just didn't write it, right? Yeah, it should be 12, not 13. And because I said the length was 13, and then I was thinking that. But yeah, the height is definitely 12. My math didn't work out if that was a 13. It wouldn't have come out to 100. That's it. Cones, pyramids, 1/3 base times height. Not the hardest thing in the world to have memorized. All right, we are going to use that in a slightly harder problem. This one says the volume of a trapezoid base pyramid is 572 centimeters cubed. What is the value of B? Now, a lot of you guys don't take this to heart, but a lot of you would very benefit from what I'm about to do. If I'm not sure what the problem's asking, I'm going to write the volume formula down and see what I can fill in. So I'm going to say, okay, the volume equals 1/3 the base area times the height. And why I do that is because guess what? 572 is the volume that we're talking about. It says the volume equals 572. So I know for a fact that's going to go there. I also noticed that they gave me this 22. This 22 is the height of that object. Remember, a height forms a 90-degree angle. If we can picture this is 90 degrees, height forms a 90-degree angle, so that must be the height of 22. So we actually know the height as well. The only thing I don't have is the base area. So now all I'm thinking about is, hey, let's draw that base down below and come up with the area of it. So this base right here is a trapezoid. It's a trapezoid where one of our bases is 8. The height is 6, and the other base is B. The area of a trapezoid is 1/2 the height, which is 6, times base 1 plus base 2, so that would be 8 plus B. You do need to know the area of a trapezoid, so you need to know that. Once again, it's half height times base 1 plus base 2. All right, that's going to equal 3 times 8 plus B. Distribute that 3, and you should come up with 24 plus 3B. That is the area of the base. So now what I'm going to do is I'm going to kind of block off what we just did here. That's already done. I came up with the area of the base. Now I'm going to plug in the information I know. I know my volume is 572, so we're going to put 572 in for that volume. We'll go 1/3. My base area, I'm going to put in parentheses as being 24 plus 3B. And I'm going to multiply that by the height. The height was 22. Well, now I just have a variable to solve for. So we are just solving for b. So let's go step by step and solve for b. So the first thing I'll do is I'll distribute that 22 to both of these things. I would have 572 plus, or not plus, but equals 1/3. What's 24 times 22? Tori?
528.
528. And that'll be plus 66b. Now we are going to distribute that 1/3. So I'm basically dividing everything by 3. So we have 572 equals, what's 528 divided by 3? Yeah.
176.
176, thank you. Plus 22b. Now I'll subtract 176 on both sides and divide everything by 22. You should come up with b equals, what would that be, 18? Is that right? 18 centimeters. I heard some head nods, so my mental math was right. A lot of you would have benefited this on your test. There were some that gave you the area of something and then you had to solve backwards. If you're ever stuck, just write the formula down and see what you can plug in. Because even if you get stuck, at least I know what you're thinking about and what you are plugging in to try to solve it. The harder you make it seem on how you're solving it, so you might think you're being clever by hiding stuff and putting stuff in different locations. If I can't read what you're doing, you just lose more and more points as we go down the line.
Are you getting the test back today?
You already have your test back.
We do. Oh, is it in there?
We got them in class yesterday, but you weren't here in class yesterday, so it'd be in your mailbox. Yep, that's fine. All right, any questions on that one? All right, that's all we have today. The only thing we learned today is the volume of a cone and a pyramid, which is the exact same thing. It's half your base area times your height. So, three-dimensional object, base area times height. Whenever it comes to a point, it is 1/3 base area times height. Base area times height, 1/3 base area times height. Don't take the time to memorize every single shape. Don't go, okay, I need to memorize that the circle on the bottom. I need to memorize this. Just know base area times height and 1/3 base area times height. The less taxing you put on your brain, the more likely you are to remember this stuff on the test. All right, guys, the rest of the time is yours to work. Make sure you work hard so you can ask questions. I'm also going to walk around and I'm going